Hi, I'm Dave Robinson, and welcome to another screencast where I'll be analyzing and exploring data in R that I haven't seen before. As usual, this dataset comes from the Tidy Tuesday project, which every week releases a new dataset, and let's see what we got this week. It's going to be a dataset on dairy production and consumption. All right, I'm excited. So we have a lot of CSVs this week. All right, and it comes from the U.S. Department of Agriculture. Let's see. So the original data requires a lot of messing with Excel sheets. Maybe we'll get to that today. Let's see how we, no, maybe not. There's quite a few CSVs that we already have to work with. All right, and it comes out with two articles. Sometimes I check out the article near the end. I don't like to use it. I don't like to look at it yet because it'll affect how I explore the data. I like to see what do I find interesting about the data first. All right, we have 5 CSVs. Ooh, it says might require a few tame data sets. Okay, so one thing it's saying is that fluid milk sales, milk cow facts, and state milk production are good for just plotting, and milk products and clean cheese allow for some creativity in the data organization steps. Maybe I'll start with one of the milk, let's see, milk cow facts looks like it doesn't have a lot of columns. Oh, sorry, fluid milk sales looks like it doesn't have a lot of columns. Maybe I'll start with milk cow facts, then move on to one of the ones. This is going to be interesting. This one probably is going, cheese and milk product facts, probably move on to those afterwards. You know what? I think I will start with milk products facts. Let's start with a slightly data set that requires a little more creativity and exploration. So I'm going to, your mileage may vary. You could choose another data set. I'm going to start with this one, milk products facts. All right. What I do is go to the appropriate page, click raw, and grab the link. And then I open up my RMD. I'm going to save this one as US Dairy Library Tidyverse. Oops. And I'll do read CSV milk product facts. Products facts. Facts? Let's look at what data we have. Put it into view. All right. So this is going to take a gathering step because we can see it has one column for every type of dairy. Now one trick is, let's see what the units are because I'm seeing very different numbers. Let's see. Average milk consumption, it looks like it's always, am I right that it's always pounds per person? Yes, looks like it. Okay, then this isn't too hard a tidying step. This is a classic case of gathering. I have one column year, and really my two other variables should be type, or let's say product. So I want to gather product and pounds per person for everything except the year column. So that's my tidying step, where now I have year, product, pounds per person. So I could ask a lot of questions. For one thing, I could say, so this is milk products tidied. I could ask just about the most recent year. I could say filter year is, I'll sometimes say max year. I don't know what the max, I didn't know what the max is yet. Looks like it goes 2017. And I could count the product and the pounds per person. This is me just interested in getting a feel for the data. Anytime I do a bar plot like this, I want to flip the coordinates. I'm going to spread this out a little. And I also, if you've seen my screencast before, you know that I'm probably going to do an FCT reorder of product by pounds per person. This lets these items be sorted. The other step I want to do is, I don't love it being, we call it snake case with the underscores. I would like either, I'm going to try making it title case. So before I reorder it has to be before, I do string to title which should turn this into title case. Ah, but it doesn't remove the spaces. Oh, okay, I get it. I would need to do, yeah, I think I would have to, inside, do string replace all the underscores with spaces, and then do string to title on that. Here it is. I have the option of doing string. Can I do sentence case? I actually don't know. Nope. That's okay. Maybe I could do upper. String to upper. And that would be, oh no, not all uppercase. I meant just the first letter. Not worth it. String to title. This looks pretty good. Usually, if I were doing this as a graph, I would probably remove the x-axis label, make the y-axis label pounds consumed per person in 2017, and this just gets a general sense that, like, yeah, the average per U.S. This is a person in the U.S. drinks lots of milk, some various kinds of cheese, some yogurts. Okay, that's solid. Another way to think of this is that notice we have category: fluid, cheese, frozen, evaporated, dry, another type of cheese, other. So we actually have some categories within this. That is going to be relevant when we look over time. I'm not gonna. No, I'm going to take a. I'm going to try taking a bit of a look at that. Excuse me. Is it always the first word? Yes, it is. Okay. So I think I have my milk products tidied. I'm going to do the processing in here. No, I take it back. I'm going to do the. Yeah, I'm going to do the processing afterwards. I'll show why I'm thinking about that. I did a gather. Now I have fluids, cheeses, dry, everything. I actually want to separate those into two columns. I want to call them category and product. And I'm doing this a bit wrong. I separate product into two categories, category and product. The sep is underscore, and when I have extra, I merge. What do I mean by extra? What I mean is in cases where it's ice cream regular, I'm going to quickly count category and product. Could have done distinct, but I want to leave these all merged. So I want to say extra merge, and I also want to say fill equals right. Yeah, which will allow me to say butter, and the product is also butter. So butter is a bit odd because it's the only one that has this like sentence and this this category on this product at the same time. And in the same place. So I might want to throw in one more step, which is if there's no product, I want to be coalesced between the product and the category. So what does coalesce mean? Coalesce means if it's an A, if the category is an A. Oh, my mistake. Oh, no, nope, I did it right. This, product and category. If the product is an A, drop back to the category. So when product was an A, use butter. Okay, so this is my cleaned version. Why did I go through the work of doing that? Why did I separate category and milk? I also will probably want to do, so I did a coalesce. I probably also want to do my string to title, string replace all on the product. I probably also want to say category is string to title of category. I'm just going to make it look a little bit better. Fluid, fluid, etc. If I distinct category and product now, it looks pretty great. Yeah, there we have our categories. Why am I doing it like this? Well, I'm going to save this as milk products tidied. It's because I might want to aggregate across years. This is important because we have too many categories to make a line plot over time. So I can do, but I can instead do group by category and year. Well, first thing I can do, let me quickly notice, I've made this graph. Oh yeah, I need this step. I don't know what's up here. I can do this. Can I do this step? I can. Can I do this? List of length 9, not meaningful. I don't actually know what this... I have not seen this bug before, I don't think. Okay. Oh, I see. I accidentally had an extra greater than sign up here. Okay. I reordered the product. Okay. I can't. The problem here is that there's multiple other categories. Oh. If I reordered this with sum, and then I said fill equals category. Yeah, that's closer to what I'm looking for. Excuse me. That is to say, I want to say there's other cheese, and there's other frozen. Or should they really be combined? It's hard to say. But this is one way of visualizing 1 year per category. But this is not as important as, this is not the only kind of graph I wanted. I wanted to say group by category and year, and summarize pounds per person is the sum of pounds per person. Combine the categories, everything from butter to frozen to fluid. And I wonder if people have been moving from fluid to evaporated, or fluid to frozen. If I wanted to answer a question like that, I could say year, category, year, pounds per person, color is category, and geom line. Whenever you get an error like non-finite location, it just means it couldn't find something. What's actually interesting about this is that it looks like fluid consumption, almost certainly milk, has been going down over time, and cheese consumption been going up. Frozen, down a bit. Okay, so this was one way I wanted to aggregate all the data. We have a problem whenever when I'm going to be comparing anything on a line, which is that we have that milk category is kind of taking over everything. Sometimes we don't have any way around it. That's by category. This would be, I would call it consumption by dairy category. Dairy consumption by category is what I'd name this. Y is pounds per person. X is still year, but I can capitalize it if I like. And then I'd say based on US consumption. USDA, source USDA. You can sometimes add details like that to a subtitle. You know, it's not a bad graph. I don't think it's not the most informative we could get. I'm going to quickly change our ggplot2 theme and come on back. Okay, it's one thing we learned. That was one way of working with these many categories. I'm going to suggest two other ways. One is FCT lump. I could say that I use that a lot in these screencasts. I say product is FCT lump of product into the top 6, and plus another category, and I want to weight it by pounds per person, and I want to group by both product and year. And I want to summarize pounds per person is sum of pounds per person. And if I graph this now, using a very similar graph, where I say year, pounds per person, but I say color equals product, what I get is American cheese. So milk's been going down. American cheese has been going up a bit. Yogurt looks like the real winner here. It looks to me like yogurt has been increasing. Look at that. Okay. Man, it's having milk on this graph. It just is kind of taking everything over. One thing I realized, separating out the category can make it a little bit confusing, where it's like what American what, but I can add a few more categories. Probably not really helpful. Another way that I mentioned there are two ways that can try and show everything. Another is I certainly can't do product without doing a summary. Look at what this is going to look like. Too many colors in the graph. In fact, we have two other categories. Because I did that separation, we have two other categories. But even if we didn't, way too many categories. No good. But what I could do would be facet wrap by product. It's still not going to look great. It's going to be too many graphs, too many points. But I could say scales are free. I got to deal with this other. I promise I'll deal with it in a second. And throw in an expand limits. I always, when you do, especially in a case like this, I need all the y-axes to start at 0. And yeah, the problem with other is that it's only meaningful if it's like frozen other or cheese other. So I'm going to get that actually in the cleaning step. What I'm going to say is product is if else product if the category, nope, I take it back. If the product is other, then paste the category and the product. Actually, the product and the category. I realize I kind of like the name other cheese rather than cheese other. Otherwise, just leave it at the product. What did that do? What that did is, if I try this faceting again, it's going to have 17 groups, which I'm not crazy about. Nope, it didn't work. Oh, other only became capital after these other steps. That was a little issue. When you do these multiple mutates in a row, you really got to watch the order. I've kind of got a mental model going of what they are at every step, but I still I certainly make mistakes, and it can be useful to just run one mutate at a time and look what's in between. Okay. I don't love making a facet when there's something like an odd number, or like a number that doesn't naturally lend itself to a grid like this. But this actually does get across a lot of the idea. What we can see is that yogurt's on the up and up. American cheese been increasing. Milk consumption has certainly been decreasing, which is funny because the 80s I associate with Got Milk and the ad campaign and the USDA's push for more milk. But we have other ones that are flat. Whenever I see lots of trends and I just want to say which are going up and which are going down, I'd often want to fit a model to each. I'm not sure I'm going to do that in this case because, so normally what I'd often do would be fit linear models to many of these. Oh, I could do forecasting. I hadn't thought of doing forecasting. I think that's what I'll do next, actually. I think we might want to say, what is the future of milk? What's the future of American cheese? What's the future of whey? In the process, you're going to have the great adventure of watching me remind myself how to use, how to do a forecasting model, because it's been a little bit of time. So this is going to be a great adventure for all of us, doing forecasting in a tidy way. Just like about a month ago, we did some dolphin data, and we looked at and I did survival analysis, and it had been a while. Okay, so I'm going to remind myself a couple things. I'm going to remind myself the forecast package. Here we go. Can the forecast package take? So I've done it sometimes before. It's been about a year and a half, I think, since I last did forecasting, and I'm certainly no expert. I'm also trying to remember if Broom, if I do library Broom, no forecast tidiers. Remembering what I have in Broom. Oh, not STM. I actually wanted. No, it's not seasonal. I don't need I'm just gonna say forecast. Ah, yes, the sweep package. I haven't. This is fantastic. It's built by the people at I think Business Analytics, like Matt Dancho and Davis Vaughn. Fantastic package. I just need to remind myself how it works. This is going to be, like I said, it's going to be a real adventure. Here we go. Oh, a lot of these is exactly right. Do I have sweep? This is actually going to be a little adventure in seeing how I'd learn how to use a package. Last time I did forecasting, I don't believe I used the sweep package, but I am generally familiar with it. Let's see. I can look at its vignettes on CRAN. I'm going to start with forecasting at scale. Okay. Forecasts on groups. I want to nest TS. I'm moving a little fast through this documentation because I'm generally familiar. I just want to feel confident in the approach. Map to the data your TKTS. Okay. I'm seeing TKTS is time-based. Okay. What I'm going to do is I'm actually going to try this on one example first. I want to, for example, filter product equals milk. Yeah, it should only be the one fluid milk category. What happens when I do TKTS on it? TKTS? Oh, I think I need timetk package. No date or date time column. Okay. I need to tell it that it's a year column. Let's see. Okay, I think I may need to turn this year column. I'm not 100% sure about this. Again, I'm learning along with you, but I think I need to turn it into a date column. So I'd say as date 1975. I'm actually going to do it a little bit differently. What I'm going to say is, let's take the year 0. There is no year 0. Take the year 1 and add the number of years to it. Years, year. Years, I think, is a lubridate function. Ah, here we go. We're quite close. I just need to subtract 1 year from it. So this was my slightly silly way of saying I want to turn every one of these into a date. Like I said, there could be a better way. What happens if I do TKTS to this? Oh, I need to pipe it into TKTS. It keeps the date, it understands the date, but it drops, let's see, TKTS. What if I say start equals 1975? Oh, I put that in the wrong place. What is select? Give me a moment while I'm actually going to go back to the original vignette and see how do I create a TKTS object. Alcohol sales is going to have this date and price. And here I would say start and freak. I would probably say freak equals 1. I don't understand why it's saying, oh, it's dropping the non-numeric. Oh, okay. Product and category makes sense to drop. I don't quite see why it's dropping year, because year is my date column. Oh, maybe it just doesn't need year because I already said See, this is what I'm not really understanding, is I feel like this is the date column, and why does it... column is... Why do I need to tell it which column is the... Why is it dropping my date instead of... I don't really understand why. Does it need the year column? If I remove the year column, would that change something about it? No, it likes it. I'm a little confused. If I said date is this, no, it would then remove the date column. Yeah, it's a, I don't know why it's saying year is a non-numeric column. I kind of just thought it would be a date. I'm just gonna stick with this for now. But yeah, that so far is the gist is that when I have one column, I probably want it. Here we go. I want to change it to date. So my category may have my product. And this is the code I would use to turn into a date. Why does that matter? It matters because I can nest by everything but category and product. Now I've got one data frame for each of these, and now I can do what the vignette was recommending. I can take that column and say TS, that the time series would be map on data, the TKTS function with the two arguments start and frequency. I think the vignette took a slightly different approach, but it should be the same idea. So if I took pull TS, I should get a long sequence. Every one of these is a time series column. Okay, so that, here we go. Let's quickly take a look. Great. Okay, that gets my time series. So I can call this milk product TS. We now have for time series, we now have a row for every individual milk product that has this column whose class is TS, this special business analytics defined class for a tidy time series. There are other tools for work with time series. I could have worked with them. These I think are generally well designed to work with their implementations of the Broom tidy augment glance methods. So why does this matter? Well, I could do, I can map to TS. I can map, I believe it's called SW for sweep glance. And, oh, you can't glance. Oh, no, I actually want to do, my bad. I want to do a model on every one of these time series. I could use ETS. What is ETS? It's, I believe, a forecasting, exponential smoothing. Oh, no, it's error trend seasonal. It's an exponential smoothing error trend seasonal model. That's exciting. Oh, wow, we've just fit 17 models just like that. We don't yet know what to do with them, but I could glance at all of them. I could find out the model parameters. That would be map model glance. You just told me that you could glance. Oh, you cannot. No. Oh, SW glance. Their version of glance. What this does is give me the model parameters for each of these fits. These include an, here we go. Oh, that's, this is interesting. It looks like a problem in printing the table. No, okay, no good. We're back to normal. This is everything from an AIC to BIC, which are criteria for choosing between models. The root mean squared error, the mean absolute error. These are all ways of evaluating these fits. They're not the easiest way to compare between these. It would be hard to say which of these models was better than others because the underlying data is on different scales. Milk has much larger numbers, so I wouldn't pay too much attention to this, but we could compare multiple models for the same data using something like AIC and BIC. That's really exciting because later we might try a different model, on a forecasting model on this data. So here I'm going to call it milk product ETS. I can glance at it, but I can also unnest the augmented version. What's exciting about augment is that we have the we have time, what they're calling index. We have the actual value, that's the original we put in, and then we have the fitted value according to this the ETS model. So this makes it easy to visualize. I can say index. I can say index on the x-axis, the, let's see, actual on the y, geom line. This is going to be, and facet by, let's say by product. I think that'll have one row for each. I'm not going to use categories yet. I probably want to do the same thing I did before and free up the scales equals free y. So we've seen this graph before. This has one facet for each of the products. What we haven't seen is that I can now add a geom line whose, let's say, color is blue, that uses the y-axis instead of using the actual, uses the fitted values, the predictions. So this is going to add a trend on top of each of them. As you can see, an ETS model actually gets really quite close in terms of the predicted value within really astonishingly close. We don't have seasonal trends in this data, so if it feels overfit to me, maybe we could try a different model besides an ETS. What other forecasting might we have? Let's see. I'm going to quickly try ARIMA. I don't remember exactly what ARIMA stands for. Auto regression something. But if anything that I put in here, so here is my graph of my ETS predictions. I actually don't know I don't know a ton about the ETS model, so I'd have to look more into that. But if I try changing this to, nope, not ARIMA. Let's see what happens when I augment it. Oh, it just gets a residual. That's a bit odd. What would happen if I used not STM? I'll try capital A ARIMA. I don't know what the difference is between those and why one has index and one doesn't. Maybe I'll create another model later. So ARIMA isn't able to see a trend in this case. It just fits a blank line. STL is the word I was looking for, not STM. Univariate series, that doesn't help. What else do I have? I'm looking for things that have an augment method. I don't know what Holt Winters is. Oh, it must only work on periods. Let's see if there are any other recommendations. The problem with ETS I'm now realizing is that I'm fitting this trend doesn't have enough. You expect ETS when you have lots and lots of residuals. Okay. You also want some periodicity, which is not what we're looking at here. This is not a perfect data set for forecasting because we don't have periodicity. Oh, well, that's a bummer. I'm probably going about this entirely the wrong way. Forecasting using multiple models, but I'm not, this might not be the right data set for forecasting. If it is, I'm probably doing it wrong. Quickly looking through what options they recommend. This would be an ARIMA. Yeah, they have a similar approach. No, let me see. So this is similar data to what we're looking at, and it's showing. So it's showing these models as ARIMA, BETS, ETS. Remind myself ETS. Okay, I'm gonna stick to the ETS approach for now. We're gonna use ETS for forecasting the future. Okay, I was curious for a minute, but it's worth looking. It's worth figuring out more. All right, what I would do is I've got fits. Oh, this is actually really neat that they're recommending different multiple types. I might come back to this approach where we try a few different type models for forecasting, but I'm going to start, let's say, just with using ETS. All right, again, I'm learning along with you here. Here's my ETS models. You can see them in this column called model, each of which is an ETS type. I can also create a forecast column where I map onto my model the forecast function. I usually would say, I think h equals 6. H in my recollection stands for horizon. It means we're forecasting 6 steps, in this case 6 years, into the future. So if I then unnest, let me see, is it going to be it's going to be a sweep? Yeah. If I unnest a sweep onto every forecast object, what are these columns? Oh, SW sweep. Oh man, I have to remember these prefixes. Here we are. What we get is the, oh, this is perfect. What we get is the data so far and then intervals for the future. I think that they set up, notice I'm jumping back and forth between the vignette a lot because I have some senses of what each of these steps mean. Yep, it'll be colors key, group is, what is F? Is group? Oh, F in this case, the model, we're not using that. Okay, so I've unnested and now I have the actual data and then what else is in the key column? Forecast, perfect. I'm going to create a plot. It says on the x-axis is the index, on the y-axis is pounds per person, and the color is key. And the rest of the graph is going to, the graphing code is going to look pretty similar. Oops. This line is gone. We don't have a comparing fitted to actual anymore. Here we go. We have actual data going up until the current time, and then we forecast the future. 6 is actually not a lot. I'm going to try forecasting 10 years. And this is useful because I'm saying here's what we expect about the future. But it's all here we go. I'm going to zoom in a little bit. Notice that the moment where it changes from being read like an actual data to a forecasted data. But it's also important that we have confidence bounds, and we can get those with geom ribbon. We notice that there's a low. Let's start with the 80 percentile. What I do is y min is low 80. Y max is high 80, and I usually want to be transparent. Let's give this a shot. What this should do is add confidence bounds to the future. It won't add confidence bounds to the past. There is no uncertainty in our data around the past. But this gives a sense of our confidence bounds for the future. So we can see that in some cases, it looks like this model ETS, and at least our data that doesn't have our seasonal trends, excuse me, data that doesn't have seasonal trends, it looks like it mostly will predict a flat line going into the future, sometimes with a positive slope, sometimes a negative. In a case like Bay, it looks like it kind of went down, but then it kind of predicts a flattening according to the ETS model. And yeah, this is a solid way of representing future forecasts. I could do it with multiple models. So another one is called AutoArima. What function do they use to create that? Let's see. Where's my AutoArima? Do you know what damped equals true? It looks like it's another argument they used to ETS. I'm going to go ahead and skip it. Here we go. where do I call the AutoArima function? This is where I'm trying to find where this fit gets created. Invoke map. Oh, no, that's interesting as an approach. Okay, what they did, I think it's a very good vignette. What it's doing is creating a data frame where it takes each of these, it takes the name of the function and invokes it with the list of parameters that go with it. But I think that does mean that AutoArima is a function. Yeah, and that's might be the appropriate one. So right now I'm using ETS. What would happen if I changed it to AutoArima? Okay, I'm learning my way around this too. It looks pretty similar to me, which is, I think, reasonable. But what if I wanted to include both? What I could do, this is what they're effectively doing. We have our data that has one row for each of our data sets. I could add crossing model name is either AutoArima or ETS. Excuse me. And I could add, let's see, yeah, I have AutoArima or ETS, and then I say, instead of map the same function onto all of them, I would map 2. I would, let me see, invoke takes the function, oh, invoke map. I didn't even know that was a thing. Invoke map. Don't think it's going to work in my case. I wonder how invoke works. Can I say invoke mean on 1, 2, 3? I can't. Oh, I can, but it doesn't look like it's. Oh, I'd have to say list of 1, 2, 3, 4, 5. Okay. This is going to be not worth the effort. I'm not going to do it. Honestly, the models look really similar, and I think, all right, I'm giving up. I'll do it. Okay, what I'm going to do here is say I want to apply each of these appropriate functions to every item in this list. So I'm going to say map 2 on the TS data and the on the name, so model name, and on my list of TS's, I want to apply the invoke function. So this will say invoke Arima on the first TS, for example. So this would be an example of one of the things it was doing. Oh, it doesn't like that. It would need it to be list, wouldn't it? Yeah, that's like I mentioned, this gets a little bit complicated. I need to wrap this function slightly. Was it worth the effort? Hard to say, but we're getting close. What I would do next is say, yeah, I see how these models are quite different, so I'm going to be happy that I did this. What I would say is color is model name, and the take a look at what the data looks like after I've fit both the Arima and the ETS model and I've unnested them. You have your model name, you have your key for whether it's actual or forecasted, and you also have your confidence bounds. So what I'm going to do is say, here we are, I'm going to say color is model name, LTY is key. I'm not sure how it's going to look yet. That's actually kind of the best that one could expect. What we're seeing here, I'm probably going to drop the key from the I'm probably going to drop the key from this graph. The legend, I don't think it's as important. what we're seeing here is that we have a model for the future in every single graph. And this is actually kind of quite interesting. The trends that are expected are similar. So ice cream reduced fat, it's been flat for a while, we expect it to keep being flat. But the ETS model has a wide range of possible futures, and Autorima is narrower. In contrast, the non-fat milk, Arima has a very wide future, and ETS a thinner future. So this is important. For example, if you used one of these forecasts and you published it in a paper, or you gave it in a presentation to a group of statisticians, they might ask, why didn't you use this other model? This is a really good graph to have an appendix where you can say, well, here's the difference between these two models. I don't know enough about the two models to compare them. I also think a lot of the advantages of forecasting come once you have seasonal trends, which this data doesn't have. Maybe we'll see it in a future Tidy Tuesday. But I really appreciated getting an opportunity to learn how to use the forecast of the sweep package and the TKTS, the timetk package, to do forecasting on of future data. In fact, this is a really quite neat graph, though I'm worried about its size and the number of items on the x-axis. I'm going to tidy it up just a little bit. I'm going to say x is year, y is average consumption pounds per person, U.S. consumption, and title is forecasted consumption of dairy products. So notice it wasn't that complicated data set. It took a little bit of tidying and a little bit of cleaning, but the interesting part came when we started doing multiple models and for forecasting. We said, I want to predict future trends. I really appreciate the excellent vignette the business science people put together. Business science, right? Yes. Put together for this forecasting approach, because it really helped me get a sense of how to use these tools. I have some experience of using Broom, but this is a very similar approach, but different enough to be worth thinking about. I probably need to adjust these x-axis labels. While I'm tidying things up, I'm going to say continuous. Breaks are, I'm going to say, just every 20 years. 1980, 2000, 2020. And I'm also going to say scale line type continuous. I think I say guide equals false if I want to remove the actual versus forecast. Oh, I said continuous. It should have been discrete. Is it guide equals false? Let's find out. Let's find out together how I remember this. Good. I probably also want to say color is model. I could change Autorima's name to something that fits in more of a something that fits in more of a graph, is more presentation ready, but I don't think it's that essential. And this is a pretty solid visualization. Yeah. Okay. Okay, so this was taking a look at forecasting. To reiterate, the approach that we would have done, that we were doing on each of these categories, we nested it, so it had one row for every category and product. We turned each of those into a time series object. We're applying two different models, either Autorima or ETS. We then fit that model and forecast a time horizon of 10 years in the future, and then we use sweep to turn that forecast into future predictions of low 95% and 80% confidence intervals. That's something I'd probably add based on USDA data 1975 to 2017, showing 80% prediction intervals. I said confidence intervals, they're slightly different, being prediction intervals. And this is our finalized version. All right. We have a few minutes left. That was some really fun look at forecasting. I wonder, I think it might be worth seeing what else is there in the data in the data that could be interesting. Let's see. This cheese. Oh, this is all types of cheeses. I think we'd apply the exact same approach. I'm not 100% sure, but it looks like this is all milk products. This is cheese. These are not going to, oh, this is interesting. We would not have, let me see. A price. Well, let's quickly pull out the cheese data. That's gonna be my plan. Let's quickly go into clean cheese, and we'll apply some of the same approaches. Maybe we'll do forecasting, maybe we won't, but you know, cheese is pretty fun. All right. So it's a clean cheese? Sure. I'm just going to call it cheese. We know that some clean has already been done, but I'm just going to call it cheese. Ooh, this is going to take a little more processing, I think. Oh, not necessarily. Though we have one misspelling. What I do is this one doesn't have categories, so it's going to be a gather, just like the one before. We know where there's a year column, it'll be gather, type, and is this average consumption per year in pounds per person? Yes, every column is pounds per person. Pounds per person, and in everything except for year. I'm going to rename the year column to be lowercase to fit the others. I'm also going to, I just mentioned that there's a funny misspelling. If I distinct type, I can actually see total American cheese. I can use mutate. Type is FCT recode. I want to on type. I want to rename total American cheese to cheese because that's going to bother me otherwise. Now it's cheese. Anything else needs to be recoded? I probably want to turn everything to sentence case. So I'm going to say type is string to title case, I should say. Type, because otherwise I'm a little bit frustrated. Sometimes other is lowercase, and with foods and spreads, whatever. This is pretty good. Okay, and 16 types. That's going to be great in a faceted graph. Seriously. So I can actually look at year, type, cheese. Oops, it's going to be year, color equals type, pounds per person. It's the same graph. I'm not going to copy and paste, though I could have. Scales equals free y. I knew I needed an expand limits y equals 0. This is going to be 16 cheeses. It's really good for a facet. Maybe this is the one I'm going to, maybe this is the prettier graph than the other one. Let's find out in terms of forecast. I really don't know, I don't know what kinds of cheese have been increasing and decreasing. Oh boy. Oops, I say color equals type. I can do color equals type, but then I definitely want, I don't want an x-axis, a legend. I'm going to skip color equals type. Hey, most cheese is on the rise. Blue cheese has some missing data. Don't know what brick cheese is, but it's going down. Okay. All right, most of this is really similar to my earlier graph. Tremendously similar, in fact. I think the only difference, I could copy paste this. I'll need to do this. Let me see, does it start? What year does it start? That's an important one. Oh, what if blue is, I wonder if the missing data is going to be a problem. We're going to find that out together. I'm going to call this cheese tidied. Cheese tidied. Graph it. And cheese time series on everything except for type. So the year starts in 1970 instead of 1975. Cheese tidied. Yeah, it's that odd column that I don't really know why it's dropping the date. I create some time series. I want to look at blue cheese. I'm going to do this in a bit. I want to look at blue cheese. I can basically copy paste everything. That means that maybe what I should have done is combine the two sets of data, done everything together. I'm not going to do that here because I do want them in separate visualizations. But I would need just to say, let me see, model name key. All of this is correct. I just need to change this to type. Boy, isn't that something? Yeah. Wow, this really nailed it in terms of what I wanted from blue cheese. So blue cheese is weird. Wow, blue cheese got really weird. I think the AutoArima and ETS handle blue cheese differently because of the missing data. I don't have a great solution to that. I don't know immediately what to do with it. Nevertheless, this is a pretty cool. This is separately a pretty cool visualization where we would say Italian other going up, mozzarella going up, total Italian cheese going up. Are all cheeses? Oh yeah, that's right. Brick cheese. Here it is. It generally predicts staying flat based on the current trends. Okay. So we applied the same thing to cheese that we did to milk. Now that was one approach we did for today, and an alternative we could have used would have been to create an interactive visualization. We could have done something where you chose what cheeses you wanted to compare, and they popped up on a shiny plot. I think, or we could have done the same thing for milk. Both of those would have been ways to let people explore this data. All right. So that was looking at dairy products in general, everything from in general the dairy consumption by category to the most common types of dairy and how they might have been changing. And once we realized we wanted to facet it, we realized we really wanted to. Once we realized that we wanted to facet, we realized we really wanted a forecast, and we applied the forecasting method from the sweep and timetk packages. So again, I really recommend checking out these the sweep and the tidy tools for forecasting set up by Matt Dancho and Davis Vaughn. Some really cool tools for working with tidy time series data. All right, well, that concludes today's analysis. I was really excited to get to learn a bit about forecasting with all of you, and I'll see you next week.